All right, in our second video on dividing radicals, as we saw in the first video, it was really just using this quotient property, this quotient rule, on how we kind of combine or split the radical into fractions. What we're going to do in this last video, this last part that's kind of like dividing radicals, so we just kind of have to simplify these radicals or these expressions if there's a square root in the denominator. So kind of one of our rules is you can't ever leave a square root in the denominator. So something we do if this happens is called rationalizing the denominator. It's just a little trick that we can use on kind of taking the radical away from the denominator and moving it up into the numerator. So rationalizing the denominator is something that we can do in which we multiply the numerator and the denominator by the radical that's in the denominator. So if we look at the example given here, we have 2 in the numerator and the square root of 3 in the denominator. This is not simplified because we can't have any radicals in the denominator like this. You can never have a square root on the bottom part of a fraction. So this rationalizing the denominator trick is where we take whatever that radical is, square root of 3 on this one, we take that and we multiply the denominator by the square root of 3, that exact same thing, because essentially we want to multiply it by itself, and I'll show you why in just a minute. But kind of a rule of algebra is if I'm going to multiply the denominator of a fraction by some value, I have to keep the fraction balanced and multiply the top by that exact same factor. So I actually have to multiply the numerator and the denominator by whatever is in that spot right there, that square root of 3. When we do that, remember with fractions, you just go straight across the top, straight across the bottom. Across the top, when I multiply, I don't actually like multiply the 2 and the 3 to get a 6 out of this because they're not both radicals. That was our rule from the day 3 lesson. This is just going to become 2 times the square root of 3, like that. You just put those two parts together with the coefficient out front. In the denominator, we can multiply these two square roots together because that was one of our rules. You can multiply square roots times square roots. And to do that, we just multiply the radicands together. Since 3 times 3 is 9, the square root of 3 times the square root of 3 is the square root of 9. And as we learned, or as we've known for a while now, the square root of 9 is exactly 3. So this just becomes 3. All right, so I want you to notice that relationship there. The square root of 3 times the square root of another 3 equaled 3, because it was really the square root of 9. And then when we look at our fraction, we see that there aren't any common factors amongst the coefficients in the denominator. So the 2 and the 3, like 2/3, cannot be reduced. And our square root of 3 is also in simplest form. I can't break that down into any perfect square factors. So that's our final answer. That is rationalizing the denominator. Let's see how that works in a couple more problems. Here we have the square root of 24 over the square root of 5. You know, kind of like what we did in the previous video, it might be a good idea to try to merge those two radicands together within a fraction, just like we saw in that quotient rule. The only problem is that doesn't help us out. 24 divided by 5 is a decimal, so it doesn't actually make this any better. So instead, we're going to use this idea of rationalizing the denominator, because right now I can't leave the square root of 5 in the bottom part of my answer. I just can't do it. And since I have the square root of 5 in the denominator, that's what I want to multiply the top and the bottom of this radical expression by, because that's what's going to rationalize the denominator. It's going to make it a rational number instead of an irrational number. So multiplying across the top, I have two square roots there, so I can multiply the 24 and the 5 together, and I believe that's 120 when I multiply those two together. On the bottom, I have square root of 5 times square root of 5. That's the square root of 25. And the square root of 25 is just 5. So let's actually go ahead and change that. 5. All right, so now it looks like we might be done, except 120 is a pretty big number. There is a very good chance that we can take a perfect square factor out of that as a way of simplifying the numerator. So we have to think what two numbers multiply up to 120 and which one of them is a perfect square. Well, I know I can divide that by 4. And let's see, what would that leave us with? That would be like 4 times 30 is 120. Let's see, 30. Can that be divided out even more? Well, 2 times 15, but those aren't perfect squares. 3 times 10, those aren't perfect squares. 5 times 6, and those aren't perfect squares. So that's okay. That'll actually get us to what we want it to be. So I split the 120 up into 4 times 30. So square root of 4 times square root of 30 is the exact same thing as the square root of 120. But I also know that the square root of 4 actually equals 2. So we'll go ahead and change that. Just regular old 2. So we have 2 times the square root of 30 all over 5. I check to make sure that I can't reduce that fraction there, the 2/5, which I can't. I also check to make sure that there's not another perfect square factor out of 30, and that's kind of what I was doing earlier, just looking at 3 times 10, 5 times 6, 2 times 15, and making sure there weren't any perfect squares out of those factors. So that is our final answer, 2 times the square root of 30 over 5. Here's another one where we have coefficients and radicals in both the numerator and the denominator. One thing you might want to check is starting with the radicals. Can I make that into a fraction like 10/3 and take the square root of 10/3? Well, 10 divided by 3 is a decimal, so I don't actually want to do that. So instead, we're going to start by rationalizing the denominator. Because our denominator has the square root of 3 in it, that's actually all we need to multiply by. We don't need to multiply by the 5 and the square root of 3. We just want to multiply the top and bottom by square root of 3. All right, so let's see what we get when we do that. Across the top, I have a regular number, like the 3. I have a square root of 10, and I have a square root of 3. So I can multiply the square roots together to get square root of 30. That's the 10 times 3. But then I also had that just regular 3, that coefficient at the very beginning that we want to go ahead and just keep there at the beginning. If we do the same thing in the denominator, I've got the 5 that's by itself, but then I also have the square roots that can be multiplied together. Square root of 3 times square root of 3 is square root of 9, since 3 times 3 is 9. But we also know that square root of 9 is, you said it, I hope you said it, 3. So now in the denominator, I have that 5 that was at the beginning and the 3 from the square root of 9. And that becomes, well, I could actually make it 15, but now I'm noticing something else. I have a factor of 3 on the top and a factor of 3 on the bottom of my fraction. And this is really how we reduce fractions. We take common factors and divide it out. So this is just going to cancel my common factors, leaving me with the square root of 30 over 5. And because up above we had the square root of 30 that was simplified, I know that the square root of 30 is simplified here as well. So anytime you end up with the square root of 30, you know that that can't be broken down any further. All right, here's a few more. Let's just take a look at, we'll start with the one on top. 3 square root of 5 divided by the square root of 2. I would start by just checking my square roots. Can I divide those, like 5 divided by 2? It gives us a decimal, so I don't actually want to do that. Instead, let's rationalize the denominator. Let's think about what should I multiply both the numerator and the denominator by. Now, hopefully you said the square root of 2, because that is what I have in the denominator. You always take whatever is in the bottom of that fraction and multiply both the numerator and the denominator by that. Now let's see what we get. When we multiply across the top, we take the 3. Sorry about all this. We take the 3, but then we can multiply together the 2 square roots. Square root of 5 times square root of 2 is the square root of 10, because 5 times 2 is 10. In the denominator, I just had the square root of 2 times the square root of 2, which becomes the square root of 4, which, as you've seen now several times, anytime you multiply a radical times itself, you're going to get a perfect square. The square root of 4 is exactly 2. Right? The square root of 2 times the square root of 2 is just 2. When I look at this, I see my fraction, 3/2, which is simplified. I can't take anything out of that. I also see my square root of 10, and I'm wondering, can I break that down using perfect squares? And really, the only thing you can do is rewrite it as 2 times 5, and neither one of those are perfect squares. So that is going to be it. That is our simplified form for this one. All right, let's look at one more. We have 9 square root of 7 divided by the square root of 3. I start by checking to see if my quotient rule is going to help us at all. We see that that's not actually going to work because 7 divided by 3 is a decimal. So we're going to have to rationalize the denominator instead. So I want to multiply by whatever was in the denominator over there. I want to multiply by the square root of 3 on the bottom and the square root of 3 on the top within my fraction. I go straight across the top. I have the 9 that was there at the beginning, that coefficient, and now I can multiply together my square roots. Since 7 times 3 is 21, square root of 7 times square root of 3 is the square root of 21. In the denominator, I want to multiply my square roots together again. Square root of 3 times square root of 3 is the square root of 9, since 3 times 3 is 9. And that ends up being a perfect square because we multiply the radical times itself. So square root of 9 is just 3. So we get 9 times the square root of 21 all over 3. So 2 things to check. Can we simplify that fraction? Yes, we can. 9/3, or 9 divided by 3, is really just 3. And then the square root of 21, let's see, 21, if we were to break it up, we do 3 times 7 is 21, but neither of those are perfect squares, and I can't break up the 21 any other way. It's just 3 times 7, or 1 times 21, which isn't going to help us. So that is our final simplified answer.